Hi, good morning to all. Today we discuss about the cascade structure of IIR filter. As that we mentioned in the case of FIR system, here also we cascade different IIR filters. Here we cascade different IIR filters. Just check an example here. Here, as system is explained with the transfer function is h of z. Okay, we can realize this transfer function by cascading two different systems whose transfer functions are h1 of z and h2 of z. These systems are IR system. h1 of z and h2 of z, they represent the transfer function of different IR system. By cascading these two systems, we get the transfer function h of z. So when we check this figure, it is clear that the input is connected to the first system. X of z is connected to first system, and first system output is connected to the second system. And we get the final output from the second system. Okay, we can check with a problem. Just read this problem. Here, an IR system is explained by this equation. We want to realize it using cascade form. Okay, so first step is that we want to find the transfer function. What is the transfer function? Transfer function h of z is y of z by x of z. How can we do that? Take the z transform. We take the z transform of this equation. You will get an equation like this one. Okay, from that you can compute the h of z, the transfer function h of z as y of z by x of z. You will get an equation like this one. Okay, when we check this transfer function, it is clear that this represents the transfer function of an IIR system. How can we ensure it is the transfer function of an IIR system? Because first of all, we have a numerator and denominator polynomial. We have numerator term and denominator term. So it is the transfer function of an IIR system, and the powers are also the negative. So we can ensure this is the transfer function of an IIR system. Then we want to realize it using cascade method. For that, we want to factorize this transfer function. When we check the numerator term, it doesn't have more factors. It is only single factor. Then we check the denominator polynomial. It have two factors. So we want to factorize the denominator polynomial. For the factorizing the denominator polynomial, the negative powers, we want to remove the negative powers. So in the case of denominator, the z raised to minus 2 term is there. So we multiply and divide the transfer function by z square. So we can remove the negative powers and you get a transfer function like this one. Then factorize the denominator polynomial. So you will get the factors z raised to minus 1 by 4 and z raised to minus 1 by 2. These are the factors. Okay, we get the factors. Next, we can convert it back to the negative powers. We can convert it back to the negative powers. We taking z from the first term and also from the second term. Then we cancel out. You will get the transfer function in the form of with the negative powers. Okay. Then we can split this h of z into two transfer functions. Okay, that is h1 of z as 1 plus 1 by 3 z inverse divided by 1 minus 1 by 4 z inverse, and h2 of z is 1 by 1 minus 1 by 2 z inverse. When we multiply h1 of z and h2 of z, you will get this equation. Okay, you can take h1 of z as this manner or in the reverse manner also. Here, these also valid, but you must ensure that each system is the transfer function of an IIR system. When we check, when we split these factors, you must ensure that each system, here we split it into two systems, h1 of z and h2 of z, both the system must be IIR system, or both the system represent the transfer function of an IIR system. How can we ensure that? It have both numerator and denominator term and the powers must be negative. Then only we can say that it is an IIR system. You can check first case is in this manner. You can take h1 of z and h2 of z, and alternative method is this one. In this manner also you can take h1 of z and h2 of z. Okay, so then what is the next step? We find the two transfer function h1 of z and h2 of z. When we multiply these transfer function, you will get h of z. Then next step is we move on to realization of each system. Okay, each system can be realized using direct form 2 method that we already discussed in the previous videos. Okay, we realize h1 of z and h2 of z using direct form 2 method. Then we cascade the system. This is the direct form 2 method of h1 of z, and this one is the direct form 2 method of h2 of z. Then we cascade the system. You will get the resultant transfer function. Okay, as that mentioned in the case of question. Okay, this is the cascaded realization of the IIR system. IIR system. Each transfer function h1 of z and h2 of z must be IIR transfer function. You must ensure that. That's all. Okay, thank you.